Hello students, welcome to Physical Science Digital Classes Mahabubabad. Myself Narendrababu Kotla, PGT Chemistry, TSMS Mahabubabad. In this session we are going to discuss natural indicators, olfactory indicators, acids and bases. In our previous session, we discussed about indicators. So in that especially we discussed about synthetic indicators like methyl orange and phenolphthalein, and also discussed about litmus. But litmus is a natural indicator. Litmus solution is purple dye. It is extracted from a type of plant called lichen. It is extracted from a type of plant called lichen. Lichen is a plant belonging to the division Thallophyta. It belonging to the division Thallophyta. It is neutral in nature. It turns red in acidic solutions, blue in basic solutions. Litmus that turns red in acidic solutions, blue in basic solutions. So one more natural indicator, generally we will use it in our kitchen, that is turmeric. Turmeric is also a natural indicator. Turmeric contains a yellow dye. It turns red in basic solutions. Turmeric that turns red in basic solutions. If you take the turmeric, if you add it to the soap solution, then yellow colored turmeric that converts into the red in color. The next natural indicator is red cabbage extract. Red cabbage extract. It is also a natural indicator. It is red in color. The red cabbage extract remains red in color in acidic solution. If you add this into the acidic solutions, then it remains red in color in acidic solutions. But it turns green on adding to the basic solutions. If you add this red cabbage extract to the basic solutions, it turns into the green in color. It turns into the green in color. Some of the petals of flowers also act as indicators. The colored petals of some flowers also act as indicators. They change color in presence of acids and bases. They change colors in presence of acids and bases. Example, hydrangea, petulina, geranium. Hydrangea, petulina and geranium are the examples. The flowers of hydrangea petals are blue in color. They turn pink in the presence of a base. They turn pink in the presence of a base. Another one is olfactory indicators. Olfactory means relating to the sense of smell. Relating to the sense of smell. Those substances whose smell changes in acidic or basic solutions are called olfactory indicators. Those substances whose smell changes in acidic or basic solutions are called as olfactory indicators. Example, onion and vanilla extract are olfactory indicators. Example, onion and vanilla extract are the examples of this olfactory indicators. So coming to the onion. Onion is having a characteristic smell. It is having characteristic smell. So take the cloth strip and treat it with the onions. If you take any one of the cloth and if you treat it with the onion, then the cloth will get the onion characteristic smell, or it gets the onion's characteristic smell. So if you add a basic solution like NaOH to this cloth strip, then onion smell cannot be detected. That means it loses its smell. So this indicates that if you add basic solution to the cloth strip of the onion, then it loses its smell. It cannot show its characteristic smell. If you take the acidic solution like HCl to the cloth strip treated with onions, it does not destroy the smell of onions. That means it remains the smell, characteristic smell of the onions. It remains the characteristic smell of onions. Second one is vanilla extract. Vanilla extract is also having the characteristic smell or characteristic pleasant smell it is having. Basic solutions like sodium hydroxide added to vanilla extract, then we cannot detect the characteristic smell of vanilla extract. We cannot detect the characteristic smell of vanilla extract. Means it loses its characteristic smell if you add it to the basic solutions. So acidic solutions like HCl added to vanilla extract, it does not destroy the smell of vanilla extract. That means if you add the acids to the vanilla extract, so it does not lose its characteristic smell, it retains its pleasant smell. That is vanilla extract. Based on these concepts, so I would like to give one sample problem to you. That is, you have been provided with 3 test tubes. One of them contains distilled water and the other 2 contain an acidic and basic solution. If you are given only red litmus paper, how will you identify the contents of each test tube? This is the question again. Right. So now we will discuss about acids. Acids. Acid word derived from the Latin word acidus or acid, which means sour. If we cut a lemon with a knife and taste it, the lemon appears to have a sour taste. The sour taste of lemon is due to the presence of an acid in it. What we have to do? Have to take one lemon, so cut it and taste it. Then the taste of lemon is sour in taste. The acid present in lemon which gives it a sour taste is citric acid. The acid which is present in lemon which gives a sour taste to it is citric acid. So with this we can give a definition of an acid, that is, acids are those chemical substances which have a sour taste. Acids are those chemical substances which have a sour taste. Acids change color of blue litmus to red litmus. Acids, they change color of blue litmus to red litmus. Some of the common fruits such as raw mango, raw grape, lemon, orange and tamarind, etc. are sour in taste. Actually, some of the common fruits we know that, and mango, raw grape, lemon, orange and tamarind, etc. are generally having the sour in taste. Due to the presence of acids in them, sour milk also contains acid in it. Acids are 2 types. Synthetic acids, which is also called as mineral acid, and natural acids. Synthetic acid, that is also called as mineral acid, and the second one is natural acids. Synthetic acids are stronger than natural acids. Synthetic acids are stronger than natural acids. The acid present in plant materials and animals are called organic acids. The acids present in plant materials and animals are called organic acids. Organic acids are naturally occurring acids. These are weak acids. It is not harmful to eat or drink substances containing naturally occurring acids in them. So organic acids are naturally occurring acids. These are weak acids. So by eating or drinking of these organic acids are not harmful to us. Okay, that means some of the substances they contains the natural or organic acids. If you eat them or if you drink them, it's not at all problem and not at all harmful to us. Some of the naturally occurring substances and they contain acids are, I am giving here some of the naturally occurring substances and they contain some of the acids in it. So those are orange, lemon. So in this it contains the citric acid. Apple contains the malic acid. Tartaric is tamarind, and unripened grape contains the tartaric acid. Vinegar contains the acetic acid. Curd contains the lactic acid. Tomato contains the oxalic acid. Gastric juice contains the hydrochloric acid. Tea contains the tannic acid. Red ants nettle leaf stings contains the formic acid. So these are the different types of the acids generally they contains. So the acid prepared from the minerals of the earth are called mineral acids. Again acids, what are mineral acids? The acid prepared from the minerals of earth are called mineral acids. Mineral acids are man-made acids. Mineral acids are man-made acids. For example, hydrochloric acid, sulphuric acid, nitric acid are the examples. Concentrated mineral acids are very dangerous. Concentrated mineral acids are very dangerous. They can burn our hands and clothes. These acids should be handled with care. Concentrated acids are very dangerous. So they can burn our hands and clothes. These acids should be handled with care. These acids should be handled with care. Actually, acids are classified into, again, strong acids and weak acids. Acids are classified into strong acids and weak acids. Strong acids means, so these are the acids. For example, hydrochloric acid, sulphuric acid, nitric acid are the strong acids. That means almost all the mineral acids are strong acids except the carbonic acid. All the mineral acids are strong acids except carbonic acid. Why? Because carbonic acid is a weak acid. Okay, right. So what are weak acids? Weak acids are, so all organic acids or naturally occurring acids are weak acids. Example, acetic acid, formic acid, citric acid, tartaric acid, carbonic acid. Actually carbonic acid is a mineral acid. Except this carbonic acid, all mineral acids are strong acids. And mineral acids are very dangerous to drink. You can eat and you can drink the substances which are containing the naturally occurring acids. That means organic acids, mineral acids. mineral acids. Okay, right, coming to here. So strong acids are very dangerous to drink, and even the dilute solutions are extremely harmful to drink. So not only the concentrated mineral acids, even the dilute mineral acids are also very harmful to us. The organic acids are weak acids. The dilute solutions of weak acids are quite safe to drink. Organic acids are the dilute solutions of organic acids are quite safe to drink, no problem for us. We can drink. Weak acids like acetic acid, citric acid, and tartaric acid are used as food ingredients. Some of the weak acids like acetic acid, citric acid, tartaric acid are used as a food ingredients. For example, acetic acid in the form of vinegar is used in making pickles and tomato ketchup. Acetic acid in the form of vinegar is used to making pickles and tomato ketchup. Tartaric acid is used in baking powder. Carbonic acid is used in fizzy soft drinks and soda water. Fizzy soft drinks and soda water. Next, again we can classify the acids into concentrated and dilute acids. What is concentrated acid? A concentrated acid is one which contains the minimum possible amount of water in it. So that means very least amount of water if it is present in a mineral acid, that is called concentrated acid. The concentration of an acid is decreased by adding more water to it. By adding water to the concentrated acid, we can reduce the concentration. Okay, so when water is added to concentrated acid, then it forms a dilute acid. A dilute acid. A dilute acid is one which contains much more of water in it. A dilute acid is one which contains much more water in it. So that is concentrated acid. Next one, diluting acids. Diluting concentrated acids. So a dilute acid is obtained by mixing the concentrated acid with water. A dilute acid is obtained by mixing the concentrated acid with water. The process of mixing the concentrated acid to water is highly exothermic, which means by adding the concentrated acid to the water is highly exothermic. What is exothermic? It releases heat energy. It releases heat energy, which means when a concentrated acid and water are mixed together, a large amount of heat is evolved. The dilution of a concentrated acid should always be done by adding concentrated acid to water gradually with stirring and not adding water to the concentrated acid. What we have to do here? So while diluting the concentrated acid, so while adding acid to the water, important thing here, we have to add acid to the water, not water to the acid. So while adding acid to the water, continuously we have to stir it. We have to add the acid and we have to stir it continuously. Okay, and we should not add water to the concentrated acid. This is because two reasons here. So when we add concentrated acid, that means when we add acid to the water, what happens? And when we add water to the acid, okay, what happens we will discuss. The first case, when concentrated acid is added to water, when concentrated acid is added to water for preparing a dilute acid, then the heat evolved gradually. So when you are adding acid to the water, when you are stirring continuously, then heat gradually releases heat. And the released heat easily absorbed by the large amount of the water, so to which acid is added. Okay, that means when we are adding acid to the water, so we have to stir it gradually. That means stir it continuously, then it releases heat gradually. When it releases heat gradually, so then the water that absorbs the released heat. So that means, so there will be no problem. But so the beaker, it gets heat only here. In the second case, if water is added to concentrated acid, to dilute it, so then when you add water to the concentrated acid, then a large amount of heat is evolved at once. So this heat change some of the water to steam explosively. So water try to convert into the steam by absorbing the large amount of the heat at once. So then steam, so that explosively, and which can leads to this splash. So the acid on our face or on our clothes and cause acid burns. Even glass container may break. Sometimes the possibility of breaking the glass container also. Not only splashing the acid on our face or clothes, possibility of breaking the container. Glass containers generally we will use to dilute this. So due to the excessive heating, so that means releasing of excess of heat. So that's why. So while diluting acids, we have to add acid to the water, not water to the concentrated acid. Okay. And finally, one more definition of acids so is there. So that is, when an acid is added to the water, it releases H plus ions. When an acid added to the water, it releases H plus ions, hydrogen ions. Then it is called as an acid. What happens when acid added to the water? Acid undergoes ionization and gives the H plus ions, hydrogen ions. It releases the hydrogen ions. That is called acid. Acid means, acid is a substance which can able to release the H plus ions in water, is called acid. Next, coming to the bases. Bases are those chemical substances which have bitter to taste. A base is a chemical substance which can neutralize an acid. What is base? Base means it is having the taste that is bitter taste. A base that can neutralize an acid, that means the substance which can be able to neutralize the acid, the substance which is bitter to taste, is called as base. Okay. So all bases change the color of red litmus to blue litmus or blue. All bases change the color of red litmus to blue. Bases are soapy to touch. If you touch the base, then they are having the soapy in the sense slippery in nature, slippery to touch. All metal oxides and metal hydroxides are bases. All metal oxides and metal hydroxides are bases. For example, NaOH, that means sodium hydroxide, is a metal hydroxide. That's why it is a base. Calcium oxide is a metal oxide. That's why it is a base. Calcium hydroxide, it is a metal hydroxide. That's why it is a base. At the same time, ammonium hydroxide is also a base, but it is not a metal, that means it is not a metal hydroxide. As it is not metal hydroxide, but so ammonium hydroxide is a base. Why? Because it can able to neutralize the acids. So one more important thing, metal carbonates, metal hydrogen carbonates are also considered to be acids. What are they? Metal carbonates, metal hydrogen carbonates are also considered to be acids because they also neutralize the acids. So when they are the substance which can able to neutralize the acid, then we can consider it as a base. Example here, sodium carbonate, calcium carbonate and sodium hydrogen carbonate are also bases. They are also called as bases. Why? Because they can able to neutralize the acids. Bases are two types, water soluble and water insoluble. Bases are again two types, water soluble and water insoluble. So water soluble bases are called alkalis. Water soluble bases are called alkalis. So most of the bases do not dissolve in water. Actually, most of the bases do not dissolve in water. Those bases which dissolve in water are called alkalis. So bases are classified into water soluble, water insoluble. So most of the bases are insoluble in water, but some bases they can able to dissolve in water, and those bases are called alkalis. The base which is soluble in water is called alkali. The base which is soluble in water is called alkali. Some of common water soluble bases are sodium hydroxide, potassium hydroxide, calcium hydroxide, ammonium hydroxide, magnesium hydroxide. These are the some of the examples. Sodium hydroxide, potassium hydroxide, calcium hydroxide, ammonium hydroxide, magnesium hydroxides are the some of the examples. So the soluble bases are most important than insoluble bases. Soluble bases are most important than insoluble bases because all the chemical reactions takes place in aqueous solutions only. That means so the bases which are soluble in water only, all the chemical reactions they takes place in aqueous solutions only. Thank you for watching this video.